Hey y'all, Miss Kennedy here from Algebra Student. Let's look at line of best fit. This is one of those rare and strange times in Algebra 1 when you are doing some estimating, and while there is an exact answer, finding a line of best fit is really saying, let's find a place where it's the most likely fit, the most probable fit for most of the time in Algebra 1. So that's kind of what you're choosing from here. So one of the things that I would encourage you to do as you're thinking through this and as you kind of think, not imagine, but visualize, where do you think that line is going to kind of run? I'm thinking if I'm just going to very casually run a line, I'm thinking somewhere right in there, right? Okay, so let's just start with that and kind of go from there. So if that's my line of best fit, maybe it is, maybe it's not, I haven't spent some really good time in it, but it's generally in the right space. Then notice over here from all of these choices have very limited y-intercepts. Remember that that's the number at the end of the equation when it's in slope-intercept form. So that y-intercept has to be 4 or 9 based on the choices here, and that's it. So either our line of best fit runs through 0, 4, or it runs through 0, 9. So do you see how we can just really quickly narrow this down from many choices? We can immediately eliminate all the +9s from what we're even considering. There's no way that this line is going to run all the way up here to 9. Now, I may have it low. It may be a little higher, maybe, but it's somewhere definitely in this area of 4 on the y-axis. So if those are our only choices, then that line of best fit must be running through there. So I'm going to erase the little dot that I added here and erase my line. And now that I know that it needs to run through that y-intercept at 0, 4, I'm just going to do some better approximation. And so somewhere in here is where that line of best fit should be. And so it's very much an approximation at this point. It's definitely not just an absolute. Okay. So I'm going to put it here. Yours very well could be higher or lower, and it may be better than where mine is. Okay, so it's not so much about that. This is generally acceptable, and it runs through 0, 4. Okay, so from here, how do we get to what are our possibilities? Because we have 1, 2, 3, 4 distinct possibilities here. So I'm going to call them A, B, C, and D, just to have something to reference here. Okay, and then when I look at the slopes, the numbers in front of X, I've got 1/2, -1/3, -3, and -2. Okay, we can narrow this down again. Think about what type of slope this is. In general, is this a positive or a negative slope? It is falling as it runs to the right. And I probably, for you, I know the video's flipped around backwards, but as it runs to the right, as we go in this direction on the x-axis, our y values are decreasing. And so that is a negative slope. That does not look like an N, it looks like an R. Negative, I don't know. All right, so negative slope. So right away, I can say, okay, I can narrow this down again and know that it's not going to be a positive slope. So A is out. It's not a positive 1/2. Okay. From here, I can still narrow it some more. These are all negative slopes. And so I've got -2, -3, and then -1/3. So just in general, just know that the bigger the number for getting positive and negative, now we've already established that part, just the number itself, the bigger the number, the more vertical the line's going to be. And so a slope of -2 or -3 is typically going to be more in this direction. Whereas a fraction that's getting smaller and smaller, closer to 0 from 1, is going to be more in this direction. Okay, those are very general, just giving you an idea of what those kind of look like. So there's several options here that we can kind of do. From what I just told you, you're probably thinking, well, it sounds kind of like it might be B then. Like maybe that's the case because that fraction is going to be a little flatter, and the bigger the number in front of X is, then the more vertical it's going to be. And this is not super vertical. It's more like this. Okay, so let's see if we can kind of verify that. So there's a couple of options for sure. One would be to, take a point that's really close to the line. So let's go with this one right here. And let's kind of do, rise over run. In this case, it'll be fall over run. So it's a rise or a fall, up or down, and then running to the right. So if I do a slope of -1/3, I'm going to fall 1 and run 3. 1, 2, 3. So that's generally putting me here, which is close to the line. It's not right on it, but it's close. Now let's try, let me change colors here. Let's do -3. So that's a slope of falling 3 and running 1 to the right. Because if it's just a number, you put it over 1. Okay, so from here, I'm going to go 1, 2, 3 and run to the right 1. And so right here, I'm here to tell you that's nowhere near that line, right? It's not close. Okay, so I'm not feeling good about -3. If I do the -2, so that's going to be a slope that's down 2 and right 1. So from here, down 2, right 1, that's not looking close either. That helps me to confirm that I feel confident that it's looking like B is the right answer. Okay, so what I would do to really confirm that is just let's find a slope for 2 points that appear to be really close to this line. Okay, we have a nice rainbow of colors here going. So this point looks really close to the line, and this point that we were just using looks close to the line. To me, for the line that I drew, those appear to be the closest. And so let's think. This is at 0.52. It appears to be pretty much on those cross marks. And this, I'm going to have to estimate. It's between 2 and 3, not quite halfway there. So I'm going to call that 2.4. And then it's up 1, 2, it's up 3. Okay, so those are my 2 points. So I'm going to use the slope formula, which just says to subtract your y's over subtract your x's, right? You've seen that before probably if you're online at Best Fit. Okay, so subtract your y's. So 2 minus 3 over 5 minus 2.4. Okay, so I'm going to head over here and type this in on my fraction bar. 5 minus 2.4. Okay, I get a decimal. I can change it to a fraction, see if that helps me. -5 over 13. Ooh, that's not -1/3, but it's definitely not -2 or -3. So let's go back to the decimal. -0.38. Okay, so about -0.38. Now, -3 is -3, -2 is -2, -1/3, just in case you want to see it as a decimal here, don't remember, that's okay, is -0.33. So 3 repeating. Okay, so do you see how close that is? That's what this is saying. That's just rewritten with the decimal. negative 0.38, negative 0.3 repeating are relatively close. In this case, they're very close in the sense that they're way closer than negative 0.38 is to a negative 2 or a negative 3. So that's just a third confirmation for us that B is the right answer. And in fact, that is the correct answer. So why is it okay that it's close? You know, in algebra, there's so many times when close means it's not right. It should be exact. But we have to go back to this beginning part, that this is the line of best fit. We're looking for the best approximation, the closest in this case. And so that is why it works that way. So I hope this helps. Bye.